Question 4 is all about trigonometry. So a lake in the shape of a triangle, strange, and different paths going around the lake, fine, whatever. Find the size of angle BAC, that's this angle here. Whenever you see a triangle, you need to go through a flowchart in your mind, and the first question you must ask yourself is it a right-angled triangle? In this instance, the answer is no. Unless you are told specifically that it's right-angled, then please don't assume that it's right-angled and just chuck one in. If there's not one, it's probably not right-angled, don't assume it is. So therefore, we can't use Pythagoras' theorem and we can't use SOHCAHTOA, because SOHCAHTOA depends on having a right angle so that you can label the hypotenuse. If there's no right angle, there's no hypotenuse, cannot. Once you've decided that it's not right angled, you've got some options. Do you have pairs? So do you have a pair, a corresponding angle and side? You need two pairs if you're going to use the sine rule. Here we don't. So the last resort, unfortunately for us, is the cosine rule. The cosine rule is given on your formula sheet in two different ways. One with a small letter as the subject, that's if you're trying to find a side, and one with cos A as the subject. So let me write it out for you. It says cos A equals b squared plus c squared minus a squared all over 2bc. That's on the formula sheet. Now what's important here is that you get A, B and C correct. A can be anywhere, this angle can be anywhere. The key thing is that this angle has to be opposite this side. Big A has to be opposite little a. So if this is big A, the angle we're trying to find, then 110 is going to be little a. These two sides, B and C, must be either side, well, they're the two sides that are left over, I guess, either side of the angle that you're trying to find. So let's call this one B, and actually it would make more sense if that's big B. Let's call this one B, this one C, but it doesn't matter. So cos A is equal to b squared, 120 squared, plus 140 squared, take away 110 squared, all divided by 2 times 120 times 140. Okay, so cos A, put that into your calculator, you get a number. I don't know what it is, you'll get a number. But if we're trying to find cos of A, if we're trying to find A and we found cos A, we need to do inverse cos. So we need to cos to the minus 1 of all of this will equal to A. And that means that A comes out as 49.3 to three significant figures, 49.3 degrees. Next we're asked to find the surface area. So it's a triangle. Is it a right angle triangle? No, I cannot use a half base times height. Need to use a half AB sine C. Now this is where things get a little confusing. The A and the B, these two are sides, and the C is an angle. So if this is angle C, then A and B need to be the two sides that subtend angle C, the two sides either side of angle C. So if this is our formula, we need to apply this to this corner here, because this is the angle that I know. So area is a half, sine at the end, we know the angle is 49.3. A and B are the sides either side of it, so it's this side here and this side here. A lot of you are using this side over here. A half times 140 times 120 times sine 49.3. And on a calculator, that should have come out as 6368.3. And to three significant figures, 6370, and a units, meters squared. Before part C, we're told a bit of extra information. So a farmhouse is located at D, it's already drawn away from the lake, such that DBC, so this angle here is 80, so label that on. If they tell you anything, just label it on your diagram. That's 80, and BCD, so this one here, is 40, okay? And there's straight paths going from B to D and C to D, and we're first asked to show that BDC equals 60. So if we look at, we've got this new triangle now, C, B and D. We've got 110 meters, that'll be useful in a second, 80 and 40. We know that angles in a triangle add up to 180, so to find this leftover angle here, we need to do 180, take away 80, take away 40, which is 60. Okay, so show that you needed to see this sum here, 180, from angles in a triangle. Part D, find the distance between C and D, this part here. Again, is there a right angle? No, none of them are 90. Please do not use SOHCAHTOA or Pythagoras or a half base times sine. Do we have pairs? So we're trying to find this length here. So this length is opposite this angle, so that's one pair. This, we don't know this length here, but we do now know this angle, so we can put that in as 60. So this angle is opposite this side, and we have two pairs, which means we can use the sine rule. And the sine rule says that a side, so in this case x divided by the sine of the angle opposite, is equal to another pair. So 110 for the side divided by the sine of the angle opposite. So in this case, because I'm trying to find the side, I keep the side on top. So x is going to equal to 110 divided by sine 60 multiplied, bring this to the other side, by sine 80. Again, do this on a calculator. The answer came out to 125.087. So 125, write it all out first, and then round it to three significant figures and give a units, meters. Okay, for part E, we are told that the farmer is here at A. Oh no, his tractor is at A, he's at D, so he's got to get from there to there in the shortest possible way. And we're asked to show that the shortest route passes through the point B. So let's have a think about the different routes that he could go. Okay, he could go D to B and then B to A. That's down here, so that's one route. We'll have a look at that one. He could go D to C and C to A. That'll be down here. He could go D to B across the top, and then B to C down here, and then C to A. Or he could he go any other way? He could go D to C, C to B, and B to A. So these are the different routes he can take through this diagram. So we have to find out which one is going to be the shortest. Okay. In terms of the sides, we know everything apart from this one. So we should start really by finding that length. So how do we find this length up here? Well, look at the red triangle. Do we have pairs? Yes. So if we call this x, then the size of x over sine 40, we're going to use the sine rule, is equal to another pair. You can pick either pair. It doesn't matter. Let's pick this one, 110 over sine 60. So x is going to equal to 110 divided by sine 60 and then multiplied by sine 40. So x comes out as being 81.64. 81.6 up here, 81.64. Okay, so let's consider each of these routes and see what they add up to. We're looking for the shortest one. This one's straightforward enough. DC is 125 and CA is 120. So in total, this route would take 245 meters. Okay. DB across the top, we said was 81.64 plus 140 BA. That would come out as 221.64 meters. DB, 81.64 plus BC is 110 plus CA is 120. That would come out at 311.6 meters, so 312 meters. Okay, and then this one, DC, is 125, CB is 110, and BA is 140. So 5, 4, 6, 7, 375. So, meters. If we compare all possible routes, 375, 312, 245, and 221, or 222, to three significant figures, and we can see that this one is quite by far the shortest route. So we can conclude by saying that DB plus BA is the shortest, and obviously, obviously that goes through B. So you had to evaluate it, you had to show all possible options. It's worth 5 marks, so it's not going to be a simple one to do. 5 marks is 5 minutes though, so take your time with that one.